Hey guys, welcome to another Learn Electronics Repair video. I have a Lenovo laptop here. Another company brought in to me, just sort of repairs, and yeah, a little repair shop I guess, although the guy works from home I believe. So he brought this in and he says that it's had a new top fitted but now it doesn't switch on. So I'm assuming it did switch on before it had a new top fitted. And it kind of like came in bits, so it's not all put together. So this is what I've got, and it came with a charger. I've actually got the Lenovo charger as well, but it seems to me like the ribbon cable on the keyboard isn't fitted in here properly. It's not very long to start with, and I'm actually having trouble getting the thing to actually to grip into the socket. Yeah. So I'll see if I can get that actually to fit in, and let's see what it's actually doing. I mean, previously as well with this, I actually disconnected the battery when I first got it and just left it overnight. This sometimes solves the problem when things won't boot up, like basically a problem with the SIO locked up. So I've put the power pack on. There's don't appear to be any lights on this one. Let's have a look, see if we've got any voltage coming out of the power supply. That'll be the first thing, just to check, see if we've actually got a supply. Yeah, it's 20 volts coming out of the power pack. So we've got some power going into it. I've got the keyboard to actually clip on now. But as he says, when you press the button, nothing happens. It doesn't start, yeah. Okay, so let's get the motherboard out, I think, and let's see what this is actually doing. I have actually got, although inside here you don't have the hard drive and the CD-ROM or DVD-ROM. I do actually have those as well. Okay, let's get a bit further apart and let's have it to see what's going on. Okay, so I've attached the little on-off switch on the little ribbon. And definitely nothing's happening with this. No lights are coming on into anything. Let's have a quick look to see what we've got. So just gone to ground. This is like a little CMOS battery. I actually, that's not a good ground. Not a good ground. Oh, sorry, that is ground. My mistake. This is the positive end of the CMOS battery. This battery is like a little rechargeable battery, and it only has 2.6 volts in. And I've previously taken this off this and tried to charge it up, and I did get it over about 3.1 volts. I put it back on after a couple of days. It's back down to 2.6. So that doesn't seem to be holding a charge. It may well just be a faulty little battery. I don't have a replacement one of these. But we can see, I've just connected the power so we can have a look. So this is where the power comes into there's two MOSFETs here. And the power is coming in and out of the first MOSFET and into the second one. Yeah, and then coming out the other side of here is 0.8 of a volt, which is not a lot really. I mean, that MOSFET should either be on or off. I mean, 0.8 is 0.9 of a volt. Seems a bit of a strange voltage. I've got a buck regulator here with 1.2 on, so something's running on here, on this buck regulator, but that is the only, can't do it from the other side, yeah, 1.3 volts. That's the only voltage I can actually seem to find on this. So I can have a quick look around. I mean, there's all of the buck regulators. There's one here, nothing on there, nothing on there, nothing on there, nothing on there, another one here, nothing on there. So another little one here, tiny one, nothing on that one. There's a few more tiny ones, no. So the only power I can seem to find in here is just 1.2 volts on here, 1.3 volts. And that's all. If I have a look at the on-off switch, so let's just flick this over. Okay. So the on-off switch basically comes down to this connector here. I've got it pushed in. The connector's not very good from what I can see. But again, we can check the voltage here. So you would assume this must have like 3.3 volts to it, or at least 1.2. That's what I can see somewhere on here. It must have some sort of standby voltage on here for it to work. And if I go across all the connections on here, there's 6 connections. 4, 5, 6. There's no voltage here. This probably has an LED on it, I'm guessing. I haven't checked it out. There's definitely an on-off switch here. I can press the switch, yeah. But if there's no voltage on here, I don't see how anything can ever start up. So let's have a look at the little connector here. This is where it's connecting to the motherboard. Have we got any voltage here? So obviously we can see we have 6 connections, of course, on the motherboard here. Just get to ground again. And let's see if there's any voltage on this end of it. See if we've got a problem with the cable. No, that's okay. There isn't anything. Say it's okay. There isn't any voltage. There isn't any voltage. There isn't any voltage. There isn't any voltage. So going across all the pins here, there's no supply to there, and I'm sure, although I'm not familiar with this laptop, there must be a standby supply to the button, which effectively when you press the button it grounds that voltage and starts the laptop. That's going to be controlled by this SIO here. So we can see if we can find a data sheet for this and see if we can maybe see what voltage we have around here. I mean, another possibility is to rig up a battery so I've actually got a proper 3 volts off that battery. Maybe just an ordinary CMOS battery for now. I know it's supposed to be rechargeable, just to see if it will start with the proper voltage on there. There's some LEDs here which will light up when it powers up, so we know it's not powering up. The other thought I can quickly check, and I think it is worth checking, is if there's any short circuits on any of the buck regulator coils on this. So let's check for short circuits first, and if we don't see anything, let's check for the power to the SIO. So I can't see any coils on this side of the board. I don't see any. I mean, there may well be LDO, linear dropout, sorry, low dropout linear regulators, but I don't see any. It looks like all the power supplies are probably on this side of the board. So let's start up with this one. This is the one that's near the battery. In fact, this is probably the one that's got the 1.2 volts on it. Let's have a look. Yeah, that's the one that's got the 1.2 volts on it. Let's take the power off. So we disconnect the power. And let's see if we have any shorts. Okay, ohms range. So, well, I'm pretty obviously going to be no short on that because I actually had a voltage on it. Where are the other ones? I'll zoom it out actually, make it a little bit easier. Okay, I've zoomed it out a bit now so we can see a bit better. So this is the one that's by the battery, and we've got voltage on this anyway, so it can't have a short. This one is near the CPU, and quite likely the CPU core is reading 10. There's another one in the same area reading 8.5. One's probably the CPU core, and one's probably the PCH, which will be sort of combined with it. Here, that's not a short, 39k, whatever it is. That's another, yeah, quite a high resistance one in the kilo ohms. This one doesn't actually want to give me a reading, but it certainly isn't short. I've had these strange effects sometimes before with the meter, like it doesn't want to read certain ones. Yeah, I've got it. Okay, 560 ohms. So that's not a short. What else have we got? We've got some little ones, so these should be quite high resistors. 113. What's this one? 67. 21 kilo ohms. So I don't see any short circuits on this. I'm sure if I took out the RAM, and this might actually be the RAM. If I take out the RAM, I might actually get a different reading. Yeah, see. So that effectively, that's the RAM. I take the RAM off this and just see if it wants to power up, but it's not short. So that's what we kind of have. So I don't see any short circuits. Next one then is let's see if it works without the RAM, and if it doesn't work without the RAM, let's have a see if we find either a schematic, which would be nice, or a data sheet for the SIO at least, which would also be nice. Okay, so I've got the power on. So there was some LEDs somewhere on this. Nothing wrong. I'm soon tell if anything's happening because I also have some voltages. Yeah, does it make any difference? No, still 1.2. There's still no voltage anywhere, so it's definitely not powered up. Okay, so I can't find anything obvious so far. Let's see if we can find data sheets or schematics to help us with this one. Okay guys, I actually found a schematic which is probably going to be quite helpful with this. So let's go over to the screen capture and let's have a look what we have. So this is the schematic for ACLU9, and the motherboard I have says ACLU9 on it. So I'm sure this is the right one. And we can see down here, one of the first things we have is a voltage rail chart, which is quite handy. So it's showing that if there's no AC, that means like that's the power supply, no AC and no battery, then there's no power anywhere. If there's only battery in sleep 4, sleep 5, so this is basically when it's off, sleep 5, when it's in standby, then with just a battery you should have these voltages, B plus and 3 plus 3VL. And then it's showing you here for AC only you should have the same one, B plus 3VL, and you should have a couple more voltages, 3 and 5 volts here, and we should have some more here, so 3 volts, 1 volt and 1.8 volts. So all those should be present before you start the laptop. And it doesn't mention anywhere a 1.2 volt supply, but we know we actually have a 1.2 volt supply on there, and that's just about it. So I think the best way to trace this first is to find this voltage plus 3VL, because that should be present all the time when we've got power on. We've got the charger plugged in. I don't have the battery, but it says here AC only, so that should be there anyway. So let's find that and see where that actually comes from. So the way to do that is we just go into the press Control F to get a search box, and at the bottom we see plus 3VL, yeah, and we can search for that. And that'll find every occurrence of this on the schematic. And what you want to have a look first, because obviously this goes everywhere, this voltage, is where it actually comes from. So I'll keep flicking through until, well this is handy. This is showing as AC mode, charger in other words, and battery. And these go into, this must be an IC, PU301. And this gives B plus, which will be the output from that. Then it goes into PU401, and this gives us 3VLP. Yeah, so this is probably a buck regulator. This also might be. So we can see how this is connected up. So let's find this thing, PL301, and see what it is. So we'll put into here PL301, and it's found it. I think it looks like this here. Oh, and this is your power in, Luke. Power in, and this is your battery. So it's definitely the right place on the schematic. So this is PU301. It gives us the part number, so we could find the data sheet if we want. And this is the chip, and it's a buck regulator. You can see 2 MOSFETs, high side and low side MOSFETs. So your power comes in from your 19 volts through here, and that effectively powers this. And out comes this back plus basically, or it comes from the battery. Yes, one or the other. Okay, so we can see where this is. So let's have a look on our board now, and let's find this chip, PU301. And that's the first thing we want to check is, do we have a voltage coming out of here? This back plus, yeah. This will be, if we go back to the start, I'm sure this will be this one, B plus, back plus, B plus. I'm sure that is the same thing. Okay, so we want to find then this PL, what was it, 301. So let's find PL301 on our board. Oh, sorry, my error. It's not a PL301. it's PU301. And that, by the way, sends the B plus to PU401 that generates the 3 volt VL that we were looking for, the standby, yeah? So, okay, so it's PU301 that we want to find on the board. So I'll get the microscope, and it's there. Okay, so this is actually down by the battery connector. So this is the PU301. The part number was on the schematic, so we know what it is anyway. This is the chip. And on the schematic it showed this was a buck regulator. There was a coil nearby here, and there's a couple of FETs, PQ311, PQ312. Let's have a quick look to see if those are the actual ones that are on the schematic. So again, I'll just find it. It's PU301. I mean, PL actually took us to the right place, strangely enough. PU301, yeah, it's there. There's the chip. And there's 2 MOSFETs. And yes, the PQ311 and PQ322. So we can have a look here to see what voltage we've got. Is this where we had the 1.2? Let's have a look. Let's have a look, see what we've got a voltage here. But it should be like 14 or 15 volts, I guess, something like that. Okay, let's see what we've actually got here. So we'll just go back over to the microscope. So those are definitely the two MOSFETs that we want. There. And we can check on the coil anyway. I'll just get the meter so you can see it. I should be able to do that quite easily. So we want volts range. Let's just a bit a little closer so you can actually see it a bit better. Yeah, there it is. Okay. 1 test meter. Okay. So, would you believe now I've put it so close to the meter? I can't reach the board with it. Just give me a second while I arrange this. Right, now we can actually do something. So, this is the coil. Is this what we had the 1.2 volts on? It certainly is what we had the 1.2 volts on. And this should be like about 40. Well, there's 19 coming in. So it should certainly be more than like 1.29 of a volt. So let's have a look back at the schematic and let's see what we can see where the power comes into this. There's obviously something wrong in this area very early on. So this is your power coming in through 2 MOSFETs here. I'm not sure what the strange thing is. It's like PR301, some sort of resistor. I don't honestly know what that is. It's like a resistor with 4 legs on it, yeah. And there's that the power coming into this. ACP and ACN. Do you know, let me just go and grab, if I can, a data sheet for this. I can see where ground is. It's there. Oh no, I can see VCC. VCC is here. This is the power to it. So that's on pin 20. So we need to check on pin 20 to see if it's got any power. And we need to check on the high side MOSFET PQ311 to see if it's got any power. Okay, let's have a look at that. So it's pin 20 on the chip and it's the high side MOSFET PQ311. Okay, let's have a look. Just go back over to the microscope again. So this is the, well, one of these is the high side MOSFET, PQ311, it's this one, 311. So one side of this, it looks like that's the gate, the one on its own. So one side of this should be power coming in. And we've got almost no power coming into it. 1.28, it's on here. 0.8 of a volt. There's like no power going to the high side MOSFET, or not a lot. So there's the first problem. There seems to be no power getting to the high side MOSFET. Yeah, that must be the outside. That must be the coil side of it. This must be the supply side of it. So we need to trace that back and let's have a look to see where the power is. So pin 20 just out of interest. Now, let me just look down the microscope and count the pins from pin 1. One moment, so I can focus for you guys. Just let me check. You need to be in focus. Yeah, it's good. Right, pin 20. What's on this? So where's pin 1? Well, we'll need a torch to see where pin 1 is. Okay. Yeah, pin 1's the dot. Dot up here. There's 5 aside, so to speak. 1, 2, 3, 4, 5, 10. 15. So 20 looks like it's here. Oh, there's like a fusible resistor. I wonder if that's related to the problem. Let's have a look. So, what voltage do we have on here? I need to put my glasses back on. What voltage do we have on here? Couple of volts. So unless I can see it, and you can see it. Ah, no, that's 20 volts. So that's got power to there from the charger, but the high side MOSFET PQ311, sorry, doesn't appear to have power. Let's just get one of these. Okay, let's get back at that schematic and let's have a look to see what's going on there. Okay, well, the power comes in through a couple of MOSFETs. So let's go over and let's have a look what we have. So basically, this is your 19 volts coming in. It's about 20 off my charger. Through one MOSFET, through another MOSFET, and then this feeds effectively down to the high side MOSFET here. So let's have a look to see what we've got here. I mean, the 12 volts that comes to here, yeah. So this here, P2, this point here, P2, is connected to here and provides the VCC. So this has got power to this chip just through this MOSFET. That's where that is, yeah, P2, P2. But it has to go the long route round to get to these MOSFETs. What's on that one? So this is PQ302. Let's have a look to see what we've got there. Move to the microscope. Okay, so that's the MOSFET. Does that look a bit like, I don't know, grubby? I don't know. That's the MOSFET. Okay, let's have a look to see what we've got here. So, coming in here is 20 volts, and of course we'd expect that because we've got power to the buck regulator, and that's where it's picking it up from. So that's got 20 volts there. What's on the other side of it? Well, I suspect it's 0.8 of a volt because that's what's on the high side MOSFET's 0.89 of a volt. So that should be turned on, so that should be actually reading well, 20 volts, but it depends on what's on the gate. So let's go to the gate of the MOSFET, which is over here, and see what we have. 20 volts. So the gate's on. This should be turned on. So this should be coming out of this, you would assume, 20 volts. It's not warm or anything drawing any power as such. So it's short on it. So I'm going to just take the power off. Go to the resistance. And go to the MOSFET. The output side. No, it's like 6 mega ohms. Or 5 mega ohms. This looks to me like we've got a faulty MOSFET here. I think well, assuming it's an N channel, which I'm guessing it is, we can just check from the port number, that if that's got 20 volts on the gate, it should be turned on. Okay, let's have a quick check, make sure it is an N-type MOSFET. Ah, actually no, it's a P-channel MOSFET. So I'll just show you the data sheet. This is from the port number on here, TPC8127. So yeah, this is a P-channel MOSFET. So it's like a PNP transistor. It kind of works back to front. So this is the data sheet, and it shows all the various voltages as being negative voltages. But that can be a little bit confusing. Basically, for this MOSFET to turn on, the gate must be lower than the source. Yeah, not higher. So you've got 19 volts coming in, 20 volts coming in. So that gate would have to drop to maybe 16 to switch it on. I mean, if it went down to 0, it would be fully on. So this is activated by dropping the voltage on the gate, not increasing it. So the fact that our MOSFET has 20 volts on the gate would suggest it's switched off. It doesn't quite explain why I have a slight voltage coming out of it. You would assume that if it was switched off, there was no voltage coming out of it. Well, my meter, I guess, uses microamps, even picoamps possibly, to actually measure the voltage. The current is almost 0. So it might just be that small amount of current actually leaks, yeah. So you can say here, we see gate threshold voltage is saying -2, but you don't have to put a negative voltage on it. It just means it has to be 2 less than the source, yeah. So there you go. So that's how that works. So the MOSFET appears to be operating correctly. What we need to figure out is why we have a high voltage on the gate when we shouldn't have. So let's go and have a look to see where the gate voltage actually comes from on this MOSFET. Okay, so we need to figure out why the first MOSFET is switched on and why the second MOSFET is switched off. So let's go over to the screen again and let's have a quick look at the schematic again. So we have 20 volts coming in here and we have 20 volts coming out. So this is on. 20 volts comes to here and we've also got 20 volts on the gate. And there's nothing practically coming out, 0.8 of a volt. But this is a P-channel MOSFET, P-channel enhancement MOSFET. So normally, to switch this on, you need to reduce the voltage at the gate. If the gate is at the same voltage as the source, it's switched off. So we have to drop the voltage here. Now you can see that there's a resistor here, which comes from the 20 volts feeding to the gate. Yep, so that holds the gate voltage at 20 volts, you can see that. And the only way for the voltage here to drop is for either this MOSFET to switch on, so pulling the voltage here down, or for this one to switch on, pulling the voltage here down. Now I think you can see this is a 200k resistor and this is a 20k resistor. So if this MOSFET was switched on, what you would find is the voltage here would drop to about 1/10 of its 20 volts too. The way to actually work it out is actually to take the 200 plus 20, which is 220, and divide the 20 volts by 220 and then multiply it by 20. But a rough basis, if we just assume this is 200 not 220, then you can see the proportions of it is like 10 to 1, yeah, 10 times the resistance to that one. And from that itself, without doing the mathematics, you can work out the voltage here is about 2 volts. So that would pull the voltage down on here and turn this on. The other way was if this one was switched on, if this MOSFET was switched on, the same thing would happen. It would pull the voltage here down. This is a 68k resistor. This is a 200k. So that's about 1/3 of the value of that one. So what would actually happen if this one was switched on? The voltage here would drop to about 1/3 of the 20 volts, which is about 7. Okay, but either way, switching either of these on would switch this on. So we need to have a look to see. The other thing I just want to have a quick look at is to see if this MOSFET here is an N channel, because presuming from this circuit, if I've got power on the gate here, this is switched on, it is switched on. But I just want to make sure this actually is an N channel MOSFET as well. So let's get a data sheet for this one, which is A4407. And let's have a look. So here's a data sheet. And you can see straight away, actually this is a P-channel MOSFET. Yeah. So this works the same way. The gate voltage needs to be lower than the source voltage for it to switch on. And I haven't checked this, so we need to check this. If the gate voltage here is lower to switch this on, then it should be lower to switch that on. Can you see? They're connected together. Yeah? They're connected together. So it kind of doesn't make sense how this one can be switched on by the gate voltage being lower, while this one is switched off. Yeah, it just doesn't make sense. So let's have a look at this MOSFET and see what we've actually got on the gate, and just let's see what's going on with this device, because something here doesn't quite add up. Okay, so these are our two MOSFETs. Let's just power this up again and let's see what we've got here. Let's just check around this once more. So the first MOSFET, we know we have the 20 volts coming in on this side. There we have 20 volts. And coming out we have 20 volts. And this is the gate. And the gate has 20 volts on, so that MOSFET should be switched off. This is the 20 volts coming into this one, the second one, 20 volts. Coming out of this is practically nothing, and the gate is switched as high, 20 volts, so this is switched off. So this one is switched off, but that one should be switched off as well, and it isn't. We've got short. We've got short here. I can't think of any other reason why the MOSFET wouldn't be switched off. Okay, let's have a look. Power's off. And we certainly have got a short. So this MOSFET's short, that's why it's on. Is it short to the gate as well? Yeah, well, near enough. Something's short around here. It's looking like that MOSFET's what's short. I'll take this off. These are the other little transistors and dual MOSFETs that we can see in that circuit. I'm going to take this off and test it, but it's looking like this is short circuit. And I think now that explains why this one is switched off. Let's just go back to the schematic again. Okay, one moment, I'll just find it. There, okay. So this is short circuit. It's short circuit drain to source, and it's also short circuit to the gate. So straight away 20 volts comes onto the gate and holds this high. Yeah? And that's connected to the other gate and it holds it high. So no matter what's going on around here, this can never go low and it can never switch on, no matter what these are doing. Now, these two MOSFETs, they're actually, I think, the same package, yeah, 306A and B, 308A and B, so they're in the same package. Well, maybe those two are in the same package, doesn't matter. These two are actually connected to this point by a 20k resistor and a 68k resistor. So the fact there's a short here to 20 volts, even if this was turned on, it wouldn't damage the device because the resistor limits the current. So I don't believe there's a problem there that would actually damage any of this other stuff. But it looks very much like this is short circuit. So let's remove this and let's have a look to see if it actually is short. My usual way then to do this sort of work. Flux on the component. And then leaded solder and bridge all the pins together. You've seen me do this before if you've watched my other videos, so if that's the case you can skip over this because you know it's going to come off nice and clean. Yeah. So nice big chunky tip, BC3 tip, good blob of solder, and I've bridged the pins. Same this side, big blob of solder, and let's even go to the next one, but that doesn't matter. I've bridged the pins. I can now get hot air on this and I can melt. In fact, this hasn't bridged all off. Let me just go again. Now it has. Almost. See, the solder doesn't want to go there. It's gone. Look, I've got it. I persuaded it, yeah. So this now is an alloy of leaded and lead-free solder. The melting point will be lower than the other lead-free solder. So this will come off before any of the solder melts. Yeah, that's the theory, that's the plan. And because of that, I don't need to worry about any of the stuff around here because it won't unsolder because the solder won't melt. Because it's leaded. It's a higher temperature. Okay, so it's Captain Obvious now. So let's just warm this up. Get on this MOSFET. The only time this doesn't really work is when there's a pad underneath the component itself. Yes, if the MOSFET's got a pad which is soldered beneath it. But let's just give some warmth. Solder's melting, I can see. No, it's off. And as predicted, it's off nice and cleanly, and nothing else ever actually desoldered because the solder didn't melt. While it's cooling down a little bit, it's a good time now just to get rid of this blob of solder that I've left on here. And get rid of this blob of solder I accidentally got under the MOSFET. Oh, there you go. And that's fine. Just needs cleaning up, ready to resolder one. Okay, so let's let that cool down and let me see if I've even got a replacement for this part. No, I don't actually have replacements. I need to get some more various P-channel MOSFETs, but let's just have a quick look to see if this actually is faulty. I'm pretty confident it will be. So that's reading 0.7. That's like a short. Read the same the other way. No, it reads 26 the other way. This is the gate pin 4 at the bottom. So just touch the gate. It now reads 0.8. This is like it's switching on and off. Is it reading 0.8 this way or is it reading 26 the other way? No, 0.1. Let's touch the gate with the positive. Okay, now let's go again. It looked like it was kind of trying to switch on and off, but it was effectively leaky in between 0 ohms and 26 ohms, yeah? Okay, regardless, that is it. I have some of these P-channel MOSFETs, so you can see these are the ones AO4407A. So let's go ahead and replace one on our board and let's see if that then fixes this laptop. These are quite easy to fit actually because there's no center pad underneath them. So this is our MOSFET and you can see there's a dot here and there's a little mark in here which shows you where pin 1 is. But other than that, you can look up the data sheet. This is the gate pin 4 and you can quite clearly see that pin 4 is separate from the others, so you've got 3 source, 4 drain. So to solder this, basically you just want a bit of flux. Make sure the pads are actually nice and flat, and we can do this with a soldering iron. We don't need to use hot air on this. So we can introduce the MOSFET to the pads. Just sit it on there, get it a little bit straight. There we go. Yeah. Just lighten it up. Okay, one moment. These are actually quite easy to solder because there's no center pad, so you can do this with a soldering iron. So we've got some flux on, and the first thing I'm going to do is get some solder on one of the pads, yeah? Doesn't really matter which one. But now I've done that, I can actually get the part, the MOSFET, I can just effectively offer it up to here. Now, because I'm holding the soldering iron with my right hand, I do this left-handed, and my left hand isn't quite as steady as my right hand. But I can hold these things pretty well, so there we are, we've got it in place. Now I'm just going to stick one pad in place, just to get it to actually stick, yeah. Go on, get onto the pin, yeah. Okay, I've got it. Few attempts, but I've got it. So this is actually now fixed down, yeah, this won't actually go anywhere. So I can now quite happily come in and solder all the other pins down, so we can just get this one. In fact, if you notice it's not quite sitting flat on the board, so what I can do is I can just actually a little bit of pressure with the tweezers. It's now flat. I can now get this one here much better, yeah, that's in. Middle 2, no problem, and then we just work our way around this and solder it down. If we get a solder bridge, it's not a problem. I find using this big soldering iron tip helps me to get a lot of heat in, so I can get a good soldered joint. If I try this with a fine tip soldering iron, I find I can't actually do it so well. But you know, I mean, everybody with this game, yourselves, yeah, develop a technique that works for you, and once it's working for you, then you can just get on with it. So try and get this top one. I'll probably just turn this around now, just make it a bit easier. So alter the orientation of the board. I know for some reason I went to the wrong one. Don't ask me why I did that. Yeah, soldered the wrong one. Go on, get in there. And the flux will actually cause the solder to go where you want the solder to go. It won't. It's not what I'm doing. I'm just using this big chunky tip, getting a lot of heat in. Okay, I've got one solder bridge here. That's not a problem. A little bit of braid. And we can just soon deal with that. Okay. I mean, you may actually get rid of that just using the tip, just cleaning the tip and me coming back in again. Come on. There, you see, I've actually done it with a tip, yeah. So, I'm not the world's best micro solderer. I can do it, yeah, I can do it. There you go. And I've made a good enough job of that. So that's now in place. So we can just clean that up, and then let's give it a try and see if it actually works now. Okay, so I've just cleaned that up with a little bit of isopropyl alcohol, and you can see there, nicely soldered in the correct orientation with the dot towards the little marking there. You see this one actually goes all the way up. A dot to the marking there. So let's now power this up and let's see if it actually works. So we're ready to go. Got the power pack plugged in, so we can just attach some power to this. And let's see if it starts. Yeah, there's a light on here, so that's a good sign. I've just hit the start button. Oh, the light's on again. There's a light on. I've got a HDMI cable attached to it, so I'm interested to see if I actually get any image out of this. This either doesn't have a cooling fan, or the cooling fan wasn't fitted when the guy brought it into me. I said this has come out of another repair shop somewhere. Let's have a look. So I've got a blue light on them. I'll show you if it's working. I've got a light on here, but so far nothing else seems to be happening. I think I might just attach a few more wires to it and see what this actually does. Yeah, this is working. Basically, when I tried it with the HDMI, nothing happened. But I've put it onto VGA, so I've connected the VGA cable. Yeah, you can see it in the other shot. So we just power this up, the little light will come on. And then it takes a few seconds, but the blue light comes on the monitor. You probably can't see it. It says Asus in the top corner, and now we're getting this. So I'm going to put this back together now, and I suspect this is probably actually now going to work once I put the hard drive on it. So this one's working, guys. It's booted up into Windows. It's got a password on, so I don't know that, but it's definitely working. I mean, the keyboard works. It's typing into the little box. The mouse is working, so that's looking good. It's charging the battery. I think the CMOS battery might be a bit low, but there's not a lot I can do about that because I've struggled to get them on the island here. But hopefully it'll now charge up with the main battery charged. Okay, so there we go, guys. That one's fixed. And what did we learn? Well, I think that was actually quite interesting, in that, because you see that one of the two MOSFETs, the first MOSFET, so you got the power coming in the 19 volts, and you got the two MOSFETs. So there's 19 volts going through the first MOSFET because it's short circuit, and yet that actually prevented the second MOSFET from turning on because the 19 volts was also on the gate, and because it's a P-channel MOSFET, the gate needs to be pulled low to switch on, and it couldn't switch on. So yeah, there you go. I thought that's quite interesting. You would think that a short circuit where the power's coming in, because these MOSFETs don't connect to ground, they just feed the power into the laptop. You'd think the first one being short circuit, if anything, the thing wouldn't switch off, yeah. But no, you've seen. So hope you enjoyed that, guys. Hope it taught you something. Hope maybe if you have something similar but without schematics, that might help you in diagnosing this sort of fault. And I'll see you all soon on the next video. Lots of working, so lots of videos coming. Ciao for now, guys.